We are ready to evaluate some logarithms. This is a skill we have to get very, very, very good at. Okay, and let me take you back to the very, very, very basics of logarithms first when we're trying to figure out, okay, what does it mean to work with a logarithm? So let's work with a couple examples, and you have a couple problems on the beginning of your assignment that do this. Would you all, I hope, agree that 2 to the third power is 8? If I said write that as a logarithm, change it to logarithmic form, okay, what logarithms solve for their exponent? So therefore we would write 3 equals, because 3 is the exponent. Log with what base? Answer would be 2 of 8. That's called the argument. The number inside a log, in fact, the number inside any function is called its argument. So if you look at that, log base 2 of 8 equals 3. If you notice, if you changed 8 and made a common base, 8 is really 2 cubed. If I have a log base 2 and an exponent with base 2, logs and exponential functions are inverses. They cancel each other out. So therefore, the answer is 3. That's how we work logarithms. Okay, let me try one going the other direction just to make sure you've got it. What if I told you the log base 5 of 25 equals 2, and you translate that into exponential form? If I go to exponential form, what's the base? 5. What's the exponent? Logs equal their exponents. And 5 squared equals 25. Is that true? Absolutely. So the key thing you have to get out of this is that logs represent exponents. When you see a log, it's really solving for its exponent. That's a key concept. Okay, so now let's see if you can just work some basic log problems. You cannot punch this in a calculator. You have to do it with the brain. So let's do a few basic examples. If I said, what's log base 5 of 5 to the 17th power, what would you tell me? Well, a base 5 log and an exponent with base 5. As long as the bases are the same, the inverses, log and exponential functions cancel out. Answer is 17. It's that simple. So what if I asked you to do log base 2 of 4? Can you rewrite that? 4 as a base 2. Since that's base 2 log, can I write 4 as a base 2? Sure, it's 2 squared. That's too many 2's here, but the answer then, because the bases are the same, the answer is the exponent 2. Should have done that with a different number. Okay, what if I gave you log base 3 of 81. This is the one you know so commonly, but 81 is 3 to a power. 81 happens to be 3 to the 4th power. So what's the answer? You guessed it, 4. Okay, doing about 100,000 more of these. Let's get a little trickier. Suppose I said, what's the log base 12 of 1 over 144? Well, you would hopefully go, well, hey, 144 is 12 squared, but I can't have that in the denominator, so what do I do about 1 in the denominator? Well, of course, I bring it up as 12 to the negative 2. Now I have a base 12 log, a base 12 exponent, so my answer is negative 2. Let's try one with a root on it. Suppose I gave you log base 7 of the 5th root of 49. What do you know about 49? 49 is 7 squared in a 5th root. Well, how can I rewrite that root as an exponent? Well, it is indeed 7 to the 2/5 power. So therefore my answer is 2/5. I got the same bases. Now, let's do a couple of the special cases. What if I said, hey, what's the log of 1,000? There's no base there. So what's that mean if there's no base there? Well, of course, it's an understood base 10. So how do I rewrite 1,000 as base 10? Well, if you haven't ever learned this one, it is, count the zeros, it's 10 to the 3rd power. So what's my answer? Base 10 log, base 10 exponent. Answer is 3. And then, of course, actually what will soon be your all-time favorites. What if I give you a natural log of e to the 15th power? Well, natural logs are base e's. You love seeing natural logs and e's together. They're actually the easiest ones there are. If you see that, natural log of e to the 15th, it's just 15. What if you see the natural log of the 7th root of e cubed? Well, same old thing. Rewrite that as e to the 3/7. And ta-da, natural log and e cancel. Answer is 3/7. Now, a couple special case ones which have their moments of use. And this tends to bug people somewhat, but you can do this. As long as an exponential function and a log are together and they have the same base, they cancel each other out. So sometimes you will see 8 raised to a power log base 8 of 13. This is an exponential function with base 8. This is a log with base 8. As long as they have the same base, you got a log and an exponential function, answer is still 13. I know that looks funky, but actually it's kind of useful. The same way, if I ask you what's e to the natural log of 123, well, natural log we know is a base e log, so therefore since those are the same base, my answer is 123. So even if they're exponential functions raised to log powers, they still cancel out. They're inverses of each other. And it's that very property that we're going to use for our last part of this to solve some simple log equations. So today these are all equations with one logarithm in it. Next class we'll have multiple logarithms in our equations, but in this case it's just one, and how you work it with one is different than how you'll work it with the others. So we are actually attempting here to solve for x. Solving an equation here. I'm going to give you several basics. These can come in different forms. Okay, I want to solve for x. I know 5 is the base. I know 4 is the what? Well, logarithms equal their exponents. So 4 is the exponent. So this is called converting it to exponential form. I can change that to 5 to the 4th equals x. And ta-da, we solve for x. X is 625. Now, what you must check if x is part of the logarithm. If it's the base or it's the argument, you have to check your answer because it has to be positive values. So if I put 625 in there, can I have the log of positive 625? Yes, it's a positive value, so I'm good. Okay, that's one type of log equation. Second type of log equation would be something like this. What if I gave you log base A of 64 equals 2? Okay, now I want to solve for A. You can't really tell that's an A. Let me rewrite that. If I want to solve for A, then I need to rewrite it in exponential form. What's the base? A. What's the power? 2. That's got to equal 64. What do I then do? Normal algebra to solve it? Sure, I square root both sides. And because I'm square rooting both sides, I get both answers of plus or minus 8. Okay, do you have to check it? Yes. since the variable is part of the logarithm, you have to check again for a positive value. And, okay, if I do, can I have a log base positive 8? Yes. Can I have a log base negative 8? No. And so I would have to pitch that answer out, and my answer would only be positive 8. Now, lots of people will go, well, can I just say it's 8 and not ever write the positive or negative? No, because you have to show me you knew it was a positive or negative, and then you have to show me you also knew that you should throw it out. You don't get to be right by being lucky. You have to be right because you know your stuff. Okay, finally, probably the most challenging of these type of problems is the ones that look something like this. What if I was to give you log base 25 of the fourth root of 125 equals x? Whoa, that's kind of intimidating. Okay, notice this time x is on the other side. It's not part of the logarithm, so it doesn't have to be positive. But we still need to go to exponential form. If I go to exponential form, I can go 25 as base. What's my exponent? X equals the fourth root of 125. Now, this is yesterday's problems. You just did on your assignment. You have to make them have common bases. So what base number is in common to 25 and 125? Well, of course, 5. So 25 is 5 squared to the x. 125 is 5 cubed. So that would become 5 to the 2x. And if I change that to an exponent, that would be 5 to the 3/4. So now I am solving, the bases are the same. I could say 2x equals 3/4. I would get rid of the 2 by timesing by half and making it cancel. Since I have fractions over here, less chance to mess up. And I would get 3/8. Do I have to check? No, you do not. There's no need to check. X is not part of the log. Okay. Those take a little bit of practice, but they tend to come along with time. They are sometimes, for some people, these are more challenging than the ones that are coming in the future. Never quite sure why, other than some people are really bugged by going to exponential form. I will point out there is another legal way to work that last problem. And it is a method we may employ for some of our problems in a couple days down the road. If you don't like going to exponential form, we'll call this the alternate method. If you really are bugged by exponential form, and I'm not sure you'll find this one any better, but if I take that original problem, log base 25 of the fourth root of 125 equals x. The other stunt you can pull is what we were pulling back here on the page before. These last ones I said that looked a little strange. Over here at the bottom left, 8 to the log base 8. If I raise it to an exponential power, raise an exponential function to a logarithmic power, I can cancel out. So you can pull that stunt here if you like, because it's legal as long as you do the same thing to both sides. Since I have a base 25, I could take this and put a 25 underneath both sides and then write this raised as a log base 25 power. And I could then do the same thing here. I could make that 25 to the x power. So I literally stuck a 25 underneath the original problem and made those become exponents. Now I can say, oh look, exponent base 25, log base 25 over here on the left, those cancel. And so I'm down to 4th root of 125 equals 25 to the x power. Notice that just got me the same exact expression that I had right up here. I'm running out of space. That got me the exact same expression. I can then make common bases just like I did before. Actually, I drew that line from the wrong spot. Let's try down here, and now I got to fix. But that is an option. If that really, really, really bothers you, you can do that. We'll talk about that more as future options in a couple days. Good luck. Enjoy the logarithms.